All right, lesson 5, percent increase and decrease. Cassandra likes jewelry. She has 5 rings in her jewelry box. In the box below, sketch Sandra's 5 rings. So let's sketch those very quickly here. They don't have to be perfect. Nobody is an artist. Well, some of you are. But let's just draw them very quickly. Mrs. Smythe is definitely no artist. Okay. Then it says draw a double line, double number line diagram relating the number of rings as a percent of the whole setting of rings. And this is how we do that. The top one will be our percent. The bottom will be our number of rings. So if we start, if you notice, we have 5 rings. So if we want to represent that with percents, the easiest thing to do, because it's out of 5, would be to use 20% for each ring. So our first ring would be 1. And if we have 0, that's 0%. So for 1 ring, that would be 20%. For 2 rings, that would be 40%. 3 rings would then be 60%. 4 rings would be 80%. And 5 rings would therefore be 100%, because the total of all of her rings would be 100%. So then it says, what percent is represented by the whole collection of the rings? Well, that would be 100%. It says, what percent of the collection does each ring represent? Well, each of the rings, if you notice, would be 20%. So the next question says, Cassandra's aunt said she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? Well, if she gets one more ring, if each ring is 20% more, then it would go up 20%. So that would be a 20% increase. And if I were to write that as a fraction, that would be 1/5, because they're adding one more ring onto her collection. Okay? All right, next. John increased his trading collection by 5 cards. He originally had 15 cards. What percent increase? And use the quality percent times whole. In other words, our part equals percent times whole. So as always, P, percent, whole. Remember, our whole is always either our total, our of, our original. So in this case, originally had 15 cards. So 15 goes here. He increased by 5 cards. So 5 is going to go here, because our part will be our increase or decrease. Okay? And we are looking for that percent. And in this case, it's telling us our percent is going to be the increase. So using our formula, part equals percent times whole, we have 5 equals x times 15. Divide both sides by 15, because we are solving our equation. And these two cancel, become 1, excuse me. So x equals 0.3 repeating. So changing that to a percent, as we always do, will be 33 1/3 because when we move that over, we get 33.3 repeating, which is 33.33%. Our next question says, suppose instead of increasing the collection by 5 cards, John increases his 15 card collection by just 1 card. Will the percent increase be the same as when Cassandra's ring collection increased by 1 ring? And the answer here is no. And that's because the number of rings are different than the trading cards. Next. And I know this was blacked out here, but it had that, I believe it's Justin, has earned 8 badges. He's earned 8 badges. Okay, so that's what he's earned so far in Scouts as of the Scoutmaster's last report. Justin wants to complete 2 more badges so that he will have a total of 10 earned before the Scoutmaster's next report. Okay, if Justin completes the additional 2, okay, what will be the percent increase in badges? So when we do this one, we want to know the percent increase. And we always start with the original, which is 8. So we have P equals percent times whole. Not what he's going to end with, but what he started with, which is the 8. We are increasing it by 2. So that is our increase. And we want to know what percent that is. So we have P equals percent times whole. So 2 equals X times 8. So divide both sides by 8. So X equals 0.25, which is 25% increase. Now the next question says to express the 10 badges as a percent. Remember that word of the 8 badges, because that of tells us what our W is for this particular problem. So we have P equals percent times W. So our W is the 8 badges. We are looking for a percent, which means our 10 is our part. So P equals percent times whole. So our P is 10, our X, and then our 8. Dividing both sides by 8, we get X equals 1.2. Changing that into a percent would be 125%. Okay. Now the last question for us for today says, does 100% plus your answer in part A equal your answer in part B? And here the answer is yes. Here the answer is yes. And that's because the 8 badges, I can't spell today, people. and the 2 badges added together, the increase here would be 125%. The 8 badges is 100%, plus the 2 badges, 25%. That would equal the 10 new badges, which is 125. Oops, 125%. That is our lesson for today. We'll continue lesson 5 tomorrow and finish it tomorrow.